All right, so I think this is recording. Let's take a look at the solution of these two equations. These are radical equations. On number 9 on the left-hand side, the radical's already by itself. But in number 10, I'm going to have to get that radical by itself before I square each side. But let's jump in and start with number 9. So we've got the square root of 20 minus 8x is equal to x. And if I square the left-hand side to balance the equation, I need to square the right-hand side. That's a non-invertible operation. Therefore, when I do that, I might introduce extra solutions that are not solutions to the original equation. So this 20 minus 8x equals x squared will have the same solution set as the original equation, plus the possibility of more solutions. All right. Let's get this in standard form by adding 8x to each side and subtracting 20. And now, since this leading coefficient is 1, if we can't factor this, we can always do the quadratic formula, and we can always complete the square. But I believe that this factors to x plus 10 times x minus 2, because 10 times the negative 2 is negative 20, but when you add 10 and negative 2, you get positive 8. That gives us two possible solutions of negative 10 and positive 2, but we need to check those before we claim that they're in the solution set. So when we plug in negative 10 on the left-hand side, we have 20 minus 8 times the negative 10. And on the right-hand side, the big question is, will this arithmetic equal negative 10? Well, it never will, because this radical symbol is the principal square root. It's the positive square roots, and this claim is saying that that's equal to a negative number. That will never happen. This is an extraneous solution. It is not part of our final answer. What about x equals 2? Well, that satisfies the original equation. So if we plug in 2 for x, on the left-hand side, we have 20 minus 8 times 2. And the big question is will that equal 2? Well, 8 times 2 is 16, and 20 minus 16 is 4. And the principal square root of 4 is 2. And 2 does equal 2. This checks. And x equals 2 is in my solution set. So let's take a look now at number 10. Let's get this square root by itself. I'm going to subtract 1 from each side and add the square root of x plus 11 to each side. I'm going to square both sides of this equation. That might introduce extraneous solutions. So on the left-hand side, when I square this binomial, I get x squared minus 2x plus 1. And on the right-hand side, I get x plus 11. So let's get this equal to 0. Let's subtract x from each side. Let's subtract 11 from each side. And now let's see if we can factor this. I believe that this will factor to x minus 5 times x plus 2, because a negative 5 times a positive 2 is negative 10, but when you add negative 5 and positive 2, you get negative 3. This will give us possible solutions of positive 5 and negative 2, but we have to check them. We're not ready to say that that's in our solution set. They could be extraneous. All right, so when we check x equals 5, on the left-hand side, I have 5 minus the square root of 5 plus 11. And the big question is does that equal 1? So I've got 5 minus, well, 5 plus 11 is 16. And the square root of 16 is 4. So yes, that equals 1, and that checks. So x equals 5 is definitely in my solution set. What about the negative 2? If we replace x with negative 2, we've got negative 2 minus the square root of negative 2 plus 11. And the big question is that equal to 1? So we've got negative 2 minus. Well, negative 2 plus 11 is 9, and the square root of 9 is 3, and negative 2 minus 3 is not equal to 1, so this is extraneous, and x equals 5 is our only solution. So I hope that helps. Don't be afraid to ask questions, and I will talk to you later. Bye.